Solutions for Industrial Machinery. My name is Alex Storman. I am with SIS. I am their Marketing and Inside Sales Administrator. So let's get started. We are going to, of course, have an agenda that we're going to talk about. First, of course, we're going to talk about SIS as a whole and who we are and what we can bring to the table as a partnership. And then we're also going to talk about the current trends and challenges in the simulation solutions. Also, what are the solutions that can help you for simulation and verification? We're going to have a couple questions there for all of you. And of course, at the end, we're going to end up having a summary along with some case studies. Let's talk about SIS. Again, I'm Alex Storman. I've been with the company for about a year now. We were actually established in 1997. We have over 25 plus years of experience in CAD, CAE, and CAM and reverse engineering. Our team brings their collective extensive experience in implementing and managing engineering, maintenance, logistics, and information technical, any technical work that you possibly have any questions or needs. If you have any other questions, of course, or any you want to dive more into SIS, you can always visit us at www.sisinc.org, which I show at the bottom of the page. All right, let's dive in and talk about the trends and challenges of industrial machinery. Now, let's take a look at industrial machinery segment and some of the challenges that your organization might face. There are several of them here. I'm only going to probably base on 4 of them. So let's go down the line. Let's talk about complexity. Now, increasing automation and product configuration are 2 things that fall under the complexity side. You know, with machines that need to be smarter, and the amount of software content is increasing in machines. Machines may be able to communicate with other production machines and products they are producing with massive customization customer demands to be met. And let's go on to the safety and environmental. This is a regulatory requirement driving many aspects of machine design, along with anything that you have to be energy efficient and base regulations that's demanding with machine energy efficiency. Now let's go down the line to low profit margins. It's a large driven by global competitive pressures from low-cost providers. Margins are already critically low in industrial machinery, if you don't already know this. And I'm also going to touch on service. Service also is a manufacturer of goods in every industry except their manufacturing providers to be full service partners. They realize this presents a large profitability opportunity to help offset the low margins that already exist in the industry today. Now we're going to talk about key simulation-related trends in your industry. What does complexity mean in your industry, industrial machinery? Let's look at the modern manufacturing machines and how complex it is to develop today. Increasing product complexity in industrial machinery is so difficult now. From sensors to mechanical design to motion controls, there are many diverse requirements that modern machine builders must have at their fingertips while they are designing simulations, ultimately commissioning the machine. Speaking of complexity, let's talk about multidisciplinary worlds of machines. Now, there is a lot here, so I'm kind of going to do a good quick summary of this. Engineers need to consider various performance aspects of the machine they are developing, such as structural, thermal, noise and vibration, how moving parts of the machines will interact, how fluid and hydraulic systems will perform. But these areas do not act independently of each other. It can be challenging understanding how thermal performance will impact structural performance, for example. As a result, relying on building prototypes to physically test new design is too costly and impractical nowadays. Now what is the possible solution to these challenges? Now, I love this animated picture right here because it demonstrates the moving parts and the complexity of simulation design. The virtual simulation of the entire machine to optimize design and improve validation earlier in the process. To overcome this, machinery developers are looking to establish a collaborative, parallel, multidisciplinary engineering platform that involves simulation earlier in the development process. Now, of course, we always have one question. One possible solution for simulation and verification. What do you think that might be? Well, here we actually have a study from some data. They actually are marketing research analysis I'm sure you've heard of. They collect a lot of data to figure out what simulations today and how they can be improved. I'm going to read this to you that report actually says. The CAE is evolving from being a set of black box tools for highly specialized individuals towards a group productivity environment that delivers strategic competitive advantages to the business by supporting simulation-driven design. Now, that sounds very important when it comes to the CAE evolving. Now, here are 4 different elements of modern simulation environment. We have integrated geometry and analysis modeling, which bridges the gap between CAD and CAE modeling. It delivers a significant productivity benefits. Then you see multidiscipline simulation and optimization capabilities. They're all interconnected and available within a single user interface. A third one is system-level modeling and simulation capabilities to evaluate the system-level performance, which is very important. And the fourth and last element is the simulation data and process management to more effectively manage and keep track of your analysis data, requirements, processes, and workflow. Now we're going to shift gears into NXCAE and kind of do the breakdown of everything. I know you're all very familiar with this and you've seen this before, but I'm going to kind of summarize it as a whole. One of the great examples of modern simulation environments today is NXCAE. CAE is modern, multidiscipline CAE environments for advanced analysis, work groups, and designers who need the high quality performance, insight, in a timely fashion to drive product decisions. CAE provides the ability for a greater simulation-driven design processes by giving companies the ability to expand simulation to the design community and increase collaborations between high-end analysis and designers. Let's go over the traditional CAE process. As you see illustrated, this is the way the traditional today CAE process is done. As you can see, it's very long. It takes a lot more time than it should. I'm sure many of you are very familiar with this. Based on the process, which starts at the part of the CAD, CAE analysis spend over 80% of their time just modeling the part for analysis purposes. How bad is that? So why does analysis modeling take so long? It can be broken down into a number of steps, which can take various amounts of time depending on the type of model to be analyzed. But analysis spends a significant portion of the time cleaning the geometry to remove silver surfaces altogether. You also spend time mid-surfacing, creating fluids, and partitioning solid models for easier hex element meshing. Frustrating thing is that the entire process is repeated for every single design iteration. It can be very hard to reuse the previous analysis model using today's CAE tools. Let's see the verse between the CAE and the traditional CAE. As you see here, the chart shows the long endured process of going through the traditional CAE. And of course, what's great is that with NX CAE, you're able to break that down, faster initial iterations, and which gives you rapid updates for later iterations. Very important. So instead of having that long process you had before, we can break that down and break the time down to where you're not having to spend so much time on that. Let's talk a little bit about leveraging geometry for faster CAE analysis modeling. Referring to the productivity benefits that analysis can achieve through a common geometry in the interface, integrated geometry and analysis modeling is used. All geometry edits, mesh, and boundary conditions created by the analysis are associated to the design, which allows engineers to rapidly update their models when the design changes, provide much faster results. Let's dive into the broad range of physics simulation solutions in a single environment. Multidiscipline simulation means that multi-kind of simulation capabilities are offered from within a single environment. CAE combines multiple analysis domains under a single user interface, which is so helpful. One kind of key enabler to the system simulation of CAE is the effectively build and manage large analysis models and assembly using a multi-level structure very similar to the CAD assembly that is managed. This concept is very unique to the CAE world, as I'm sure you know. With traditional CAE tools, engineers must manually build single large assemblies. And CAE can, again, offer significant time savings in simulations to engineers. When you are increasing the number of processors, as you can see in this chart, your solution speed up goes up. Now let's talk about simulation data and processing, which we touched back in the beginning. As we look at the simulation cycle here, a moment of an engineer has to set requirements and starts working on the concept type models to the point he is validating design and correlating predictions and test data. Engineers are generating huge amounts of data, as you can see. NX users directly access data stored in Team Center and push analysis modeling and results back into Team Center to facilitate sharing with other engineering groups, sites, or even suppliers. Now we're at the time where we're going to go over a summary and have a couple case studies so we can at least put in perspective how this can help you. So in conclusion, for this actual, for CAE, it's basically significantly designed to meet today's simulation and product engineering communities. It enables you to move simulation further upstream in your development processes and make smarter decisions to help you deliver better products. Here are 3 companies that we actually have case studies on. As you can see with Frisa, we cut the cycle time by 55% while reducing costs. It really helped their productivity timing, of course. And then, as you can see, Graham Packaging Company, they actually had greater efficiency. They saved over $2 million in reducing prototype mold recuts. I'm sure you've had that problem, and I'm sure it costs several hundreds of thousands of dollars to recut it, which this is where that can save you. We also have Heidenberg. They reused the 3D data and the FEA and the kinematic speeds development. That improved their flexibility, which was important for them. So they found reusing CAD data in the NXCAE helped the great speed of FEA analysis ultimately speed up their product development. Now for a roundup for SIS, these are just some of the few things that makes us a great partner for you, which I'm sure you can see that we are a dedicated company that has, like I said in the beginning, 20-plus years in engineering and maintenance support, alongside with reverse engineering. We are always, customers are always our first priority, whether it be training on-site or off-site, or even having maintenance calls to figure out what's going on, any technical support questions you have. We service our clients to a gold status, making sure that they're our first priority, and that they are happy and they want to continue their software with us. Of course, if you have any questions about us, you can always visit our site again at sisinc.org, or if you have any questions and you'd like more information on the products or even have a quote, you can also contact me at alexandra.storman@sisinc.org. I'd like to thank you all for joining us for this webinar today and this discussion, and I hope to hear back from all of you. Thank you, and have a wonderful day.